Hi everyone, I'm Parka, a college student from Mathematics Education Department Unixa. Okay, in this next moment, I will explain to you about sequence and series concept as important lesson that we must learn in mathematics. Okay, in this video, we will talk about definition of sequence and series and also the type of sequence and series. Okay, we move to the first topic. I want to explain to you the definition of sequence and series. Okay, I think we often listen or read the text related to sequence and series. So what the both words mean? Okay, in mathematics, a sequence is an arrangement of any object or a set of numbers in a particular order followed by some rule. Simply, we also can say sequence is a set of numbers written in a specific order. The different numbers occurring in any particular sequence are known as terms. The terms of a sequence are denoted by U subscript 1, U subscript 2, U subscript 3, so on, U subscript n. Where for U subscript 1 we say first term, for U subscript 2 we say second term, and so on until the n term. Okay, for example, the sequence of 4, 9, 16, 36, 64, so on. Those are the types of sequence that we will often find, which is a type of square number sequence. So, the first term start with 4, and then next, the second term 9, next, the third terms is 16, and so on. Okay, next, a sequence can be say finite or infinite based on their terms. A finite sequence is a sequence with a clear starting point and stopping point. That means it has limited numbers of terms. For example, the sequence of 4, 8, 12, 16, 20, 24, and 28. It has 7 terms. The starting and stopping terms are displayed clearly. Then, how about the infinite sequence mean? Okay, an infinite sequence is an endless progression of discrete numbers. A sequence has a clear starting point and it is written in a definite order. An infinite sequence may include all the numbers of a particular set. We can say it has unlimited numbers of terms. For example, the sequence of 4, 8, 12, 16, 20, 24, and etc. There is a sequence have unlimited terms. Okay, next. A sequence also can be called decreasing or it can be increasing. Okay, look at the sequence of 5, 7, 9, 11, 13, 15, and etc. It is an increasing sequence because one in which every term is greater than the previous term. The rule is the n plus 1 terms is greater than the n terms. Therefore, it can say decreasing sequence if one in every term is less than the previous term. For example, the sequence which start from 70, 50, 30, 10, minus 10 or negative 10 and negative 30 and so on. Okay, next, to find the n term or the general term of a sequence, it often given using subscript notation as U subscript n. Any term in a sequence can be found by substituting its position number into a given formula for un. For example, the formula for the n term of a sequence is given by un is equal to 3n minus 5. Now we are asked to find the first 5 terms of the sequence. Okay, we know that un is equal to 3 times n minus 5. So to find the first 5 terms of the sequence, we just need to substitute a position number into un. Okay, for u subscript 1, we will get 3 times 1 minus 5, and we will get negative 2. And for the second term, or u subscript 2, we will get 3 times 2 minus 5, and we will get 1. And in the same way, we will get the third until 5 terms too. So the sequence we get by the formula is negative 2, 1, 4, 7, and the last is 10. Okay, there are some type of sequence. First is arithmetic sequence. Arithmetic sequence is a sequence in which the difference between any two consecutive terms is the same. Arithmetic sequence is also known as arithmetic progression. Okay, now let's observe the sequence of negative 2, 5, 12, 19, 26, and so on. Between the previous terms and next terms has a constant difference, and it is 7. Okay, let's make this sequence is included to arithmetic sequence. And then the nth term of arithmetic progression is given by u subscript n is equal to a plus n minus 1 times d. And for un is n term, and for a is equal to first term of arithmetic sequence, and d is the difference. Okay, the next type of sequence is geometric sequence. This sequence has a common ratio between any two consecutive terms is the same. We see that the example of geometric sequence are 1, 2, 4, 8, 16, and 32. The common ratio is the number we get after divided one term by previous term of the sequence, or it is found by dividing two consecutive pairs of terms. Based on slide, if the first term is divided by the second term, the result will be the same as the third term divided by the second term, and the ratio is 2. Then, to find the nth term of the geometric sequence or geometric progression, we can use this formula. un, or the n terms, is equal to a times r power n minus 1, and which are un is equal to n term and are the common ratio of geometric progression. Next, there are Fibonacci sequence. The Fibonacci sequence is the series of numbers consists with 0, 1, 1, 2, 3, 5, 8, 13, 21, and etc., which is the next number of term is founded by adding up the two numbers before it. The rule for find the n term in this sequence is un is equal to un minus 1 plus un minus 2. The n term will be getted by adding n minus 1 term and n minus 2 term. Okay, that's about sequence. Now let's move to the series. In mathematics, a series is the cumulative sums of a given sequence of terms. Simply, the sum of all the terms of a sequence is a series. For example, here there are a sequence of 1, 4, 7, 10, 13, and etc. If we add first term to all term until n term, that is a series. When the difference between each term in a series is constant, as in this example, the series is called an arithmetic series. Then the sum of a series containing n term is often denoted by S subscript n. So For the series given above, we could write S subscript 5 is equal to 1 plus 4 plus 7 plus 10 and plus 13. Then, when n is large, a more systematic approach for calculating the sum of terms is required by using n is equal to n over 2 times twice a plus n minus 1 times d, where Sn is n series, a is the first term, and d is the difference. Okay, for more information, when working with series, we can change Sn with the Greek symbol named sigma. That means the sum of. For the example in the slide, we can read that sign by the sum of r equal to 1 to n of ur. That means we will get the sum or series of sequence when 1 is the first value of r, or the first term we can say. Then n is the last value of r. Okay, for the example, find the sum of the first 5 terms of the series whose the n term of the form given by 4n minus 1. Okay, we can write that the sum of r is equal to 1 to 4 of 4n minus 1. And we will get 4 times 1 minus 1 plus 4 times 2 minus 1 plus 4 times 3 minus 1 plus 4 times 4 minus 1. And after we add it, we will get the sum is 36. So the first 5 terms of the series is 36. Okay, the last, if the series is a geometric progression, we can find the sum of n term by Sn is equal to a times the result of r power n minus 1 and then divided by r minus 1 for the r is greater than 1. If the r is less than 1, we just use Sn is equal to a times the result of 1 minus r power n and then divided by 1 minus r. Okay, that's all about sequence and series. I think both of them will be important to be known and to be learned. So to make more understand to this topic, make sure that try some exercise problem. That's the way to really learn math. Okay, I think it's all for today. I hope this lesson will be helpful. See you next video.